In this video, we will have the definition of a fuzzy subsemigroup and also a live example for that. So first, we have the definition. Let S and a dot be a semigroup first. A fuzzy subset mu from S to closed interval 0, 1 is a fuzzy subsemigroup of S if mu of x dot y is greater than or equal to mu of x cap mu of y for all xi in S, where this cap denotes the minimum. So the product mu of the product should be greater than or equal to minimum of mu of x and mu of y for all xy in S. So this is the definition of fuzzy subsemigroup of S. And we consider the this example where S consists of three elements and dot is defined as in this table. And we are going to check this condition live, that from the attached video you will know that when and all you can have this mu to be a fuzzy subsemigroup and when you do not have. And actually there is a result behind it, the criterion for any fuzzy subset to be a fuzzy subsemigroup. So you look at this video and search for the criterion. So in that way you will create an interest in the subject. Thank you. So here you have, we can check whether mu of xy is greater than or equal to minimum of mu of x and mu of y, where x and y are members of capital S, where the dot, that is the multiplication, is as given in the table above. So we can see that as I change my a value between 0 and 1, and similarly for B and C, how this one is satisfied, that we can see now. See, suppose I consider the extreme value for all of them, then this is what we have. We have 1 here, and here also the minimum of this one to be 1, and here also you have 1. Now if we change, suppose I change my a value and my a is say 0.83, it should lie between 0 and 1. So when we have this, then from the table we know that mu of a dot a is a only. So mu of a is 0.83, and these values, that is for B and C, we have 1 each. And here A and B only we are using. So that means mu of A, minimum of mu of A and mu of B, that will be your 0.83 because A is involved. And we are talking about this means A dot A, this. So in this case equality holds. In this case A dot B being B from the table, we have this to be mu of B, here we have as 1. So minimum of this should be 0.83 only, and your 1 is greater than your 0.83. So in the same way for the rest, we can at random, we will just move the values for A, B, C. So here you can see that A takes the value 0.83. Okay, if you want to move further down, so you have 0.74 for your A. So this is what you have, and here it is the same, right? Then coming to the next one, shall we take A dot C? Mu of A dot C being C, it is mu of C, that is 0.76, and between mu of A and mu of C, mu of C is 0.76 and this is 0.74, so the minimum is 0.74. So that is what we have, and 0.76 is greater than 0.74. So this one actually is very interesting. When we keep changing, you can notice here the corresponding values, they satisfy as you wish. You can change from here to here. You can see in all the cases the condition that mu of xy is greater than or equal to mu of x, minimum of mu of x and mu of y is satisfied. So in which case that it is not a fuzzy subgroup, condition is violated. See, here let us take. So that is, you cannot say that for all values of a and b that this is satisfied. For when it can have, I mean, we can have mu to be a fuzzy semigroup, and in which case it is not a this one. So that you can see, here you have into mark here, you have c dot b, which is a from the table, and mu of a you have chosen to be 0.43, mu of c and minimum of that with mu of b. So minimum is 0.75, 0.43 is not greater than this. In this case equality holds, so you have this. So when you choose your value in this way, then in that case your mu is not a fuzzy subsemigroup. So as in some of the cases you can see, and in some you will not have. So here for this, so here you can see, when and all you have this to be a fuzzy subsemigroup, and when it is not. So here it is mentioned. You can check on your own. This is actually from the Claude. So that has given me this. So just to know, for you to know that when you change, you will have here. It is not a fuzzy subsemigroup. It's very into mark is seen here, right? When you have like this. So from this, what is that you conclude? You keep changing. Then what is the conclusion? There is a theorem behind it. So that is left as an open question. It is there. The theory behind it, why you get this, why you don't get, and when do you get, when you do not get it. So just find it out. It is available in the literature review. When you do, it is available. Thank you.